Something is happening on the red planet! Scientists believed that they knew nearly everything about its atmosphere, but a NASA rover has discovered something unexpected. There's more oxygen on Mars than they thought, and it behaves in weird ways. In the spring and summer, oxygen levels go up even more, and no one knows why. Now, you might think that when there's oxygen in an atmosphere, it's mostly because there's life somewhere around, like trees on Earth that produce oxygen through photosynthesis. But on Mars, it's not that simple. Non-living processes can also create oxygen, so we can't surely say that its presence means there's life on Mars. Mars has long been one of the main candidates when it comes to looking for signs of extraterrestrial life. Back in the 90s, scientists announced they had spotted potential proof there could be life on Mars because of microbes they had found in a meteorite that had arrived from the red planet. It looked like they had found fossils of bacteria. They actually stumbled upon tiny crystals of magnetite in the meteorite, which they believed could only have been produced by living organisms. It was such a mind-boggling discovery. People were excited, but many were also skeptical. It didn't prove there really was life on the red planet. Maybe there was life there a long time ago. The meteorite is thought to have originally formed on Mars billions of years ago, and to have landed on Earth thousands of years ago. Skeptics soon started to pick apart the evidence and eventually found some things that didn't make sense. For example, these magnetite crystals. No one could be sure how they formed. Why do they have to be bacteria? Some research has shown they could be the result of shock waves. Recently, the Perseverance rover has collected a couple of new rock samples from the Jezero crater on Mars. The theory says that about 3 billion years ago, before the red planet lost most of its atmosphere and basically just dried out, there was a big lake with a river flowing from it in that area. Whoa, what a great environment for life! Perseverance studied mud samples it had found on the bottom of the evaporated saltwater lake. Scientists were amazed to see a record number of sulfate molecules, something we usually find in mollusk shells on our home planet. Such organisms evolved a couple of 100 million years ago, but maybe there was a time when some of their space ancestors lived in water bodies on Mars. Mars has weaker gravity than Earth, which means these weird species could have got really big there, way bigger than their Earth cousins. Gravity plays a significant role when it comes to limiting the size of organisms. Bigger organisms need more energy to move against gravitational forces, but the creatures that may have lived there long ago are just a mix of hypothesis and our imagination, something that's still really hard to prove. Meet the Curiosity rover, another robot NASA is using to explore Mars. Curiosity has been in charge of measuring the composition of the atmosphere of the red planet for many years now. The rover has discovered that it mostly consists of carbon dioxide and a little bit of nitrogen and argon. The atmosphere of Mars has only 0.1% of oxygen, since, as far as we know at the moment, Mars doesn't have plants that could produce enough oxygen. But Curiosity has also discovered anomalies no one can really explain. It's found out that there are spikes in oxygen levels in the Gale crater during the Martian spring and summer. Every year, oxygen levels go up and down in unpredictable patterns there. What's even more interesting is that the oxygen spike is similar to a seasonal spike in methane, which is a gas we often associate with life on Earth. No wonder scientists are scratching their heads and wondering if there's a connection between the two gases, and if they both come from the same source on the Martian surface. Is there something big that breathes there? Come on, we'll be happy even with some small space worms in the soil. There's a type of salt called perchlorates in the Martian soil. Some scientists believe perchlorates might be responsible for the strange spikes in oxygen levels. But like with most things we know about space, it's just a theory. Also, scientists think that perchlorates breaking down in the Martian soil release oxygen too slowly to cause and explain the sudden increase in oxygen levels. One of the suspects is hydrogen peroxide, which is like water's unstable cousin. Hydrogen peroxide forms when sunlight breaks up carbon dioxide and water vapor in the Martian atmosphere. It can seep into the soil and stick to particles underground, which means it forms some kind of oxygen storage tank. Some data even show there are pockets of subsurface water in the Martian soil that may be hiding enough dissolved oxygen to actually support life. But even if the hydrogen peroxide could stay in the soil for millions of years, it would still only explain a small part of the increase in the level of oxygen. So you can't blame it for the whole thing. We can also take a look at an old experiment from the 1970s, where scientists found that moistening the Martian soil caused it to release a lot of oxygen. However, they did this experiment at a warmer temperature than the planet's average. And again, it doesn't explain how the oxygen spike keeps happening every year. None of the clues we have seems to fit the case. Mars may not have enough of its own oxygen, but it's possible to make this gas there. NASA conducted a small experiment where they tried and managed to produce oxygen on Mars. MOXIE is a device that can make oxygen on Mars. It managed to produce enough oxygen for an astronaut to breathe for 100 minutes. This awesome device worked in pretty tough conditions, at night or during the day, at extreme temperatures, and during the crazy dust storms the Red Planet is known for. Despite all this, MOXIE still kept up with producing high-purity oxygen. MOXIE is a clever device that can make oxygen on Mars by taking in carbon dioxide from the planet's atmosphere and heating it up to incredibly high temperatures. This allows the device to pull oxygen atoms from the carbon dioxide and produce breathable oxygen gas. If we want to use MOXIE to make enough oxygen for human missions to Mars, we need to make a bigger version of the device. But if we make it bigger, we might have trouble keeping it at the right temperature and making sure it heats up evenly without breaking. The ultimate goal would be to create an oxygen device that could continuously support a human mission for about 400 days. With a bigger version of MOXIE, we'd have enough oxygen to support crew members and even propel a return rocket to our home planet. When you see the dusty red surface of Mars, you can't say it's a place that hides liquid water underneath. Some say it's too cold for water to exist on Mars anyway. But there are stories that there could be a hidden world of liquid water, just like subglacial lakes in Antarctica. And to find out more, we might have to drill down about a mile beneath the surface. Unfortunately, it's not going to happen anytime soon. But in the meantime, scientists have been using a spacecraft called Mars Express to study radar reflections around the southern pole of Mars. The reflections seem to indicate there could be liquid water, and the planet's interior might be keeping it warm. But some claim it might just be rock. We hope there are underground lakes on Mars because it would be a perfect spot to look for life. After all, scientists have found bacteria living in subglacial lakes on Earth. But we don't know for sure how deep they are, or if they're just small veins of water in the ice. Only time and more exploration will tell.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball like a marble across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity! But instead of bedsheets, we're talking about the fabric of space and time itself, or spacetime for short. Heavy objects like planets and stars make dents in spacetime, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Powell Mazur and Emil Mottola, in 2006. They tried to think, what else besides black holes could happen when a massive star collapses on itself? That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravastar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravastar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravastar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravastar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravastar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in space-time, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity. About a century ago, people envisioned the 21st century as a time filled with quirky inventions. They weren't far off the mark. We're now one step closer to establishing an actual settlement on the moon. Before we can create a new home up, we need to find a way to stay connected, beyond just transportation and shipping. Being able to send a simple text, even something as casual as, "Hey, how are you?" is essential. We can't move to the moon if we're cut off from Earth. Let me spill some tea. A lunar 4G network is currently being developed. The company leading this initiative is none other than Nokia's Bell Labs. The company, bought by the world-famous Finnish company that started out as a paper mill in the 19th century and later ventured into the cell phone industry, creating iconic devices long before Apple launched its first phone. Once the network is completed, it will be loaded onto a lander, deployed, and connected using specialized radio equipment. But don't think this is just a fun experiment. It has significant purposes. The Lunar Outpost rover, one of the vehicles involved in this mission, will thoroughly explore an area known as the Shackleton Connecting Ridge. Another rover, the Micronova, will investigate a lunar crater in search of ice. When they discover ice and capture images, this information will be first transmitted to the lander and then relayed to Earth, an unprecedented achievement in history. Moreover, the importance of a reliable phone connection cannot be overstated. Currently, astronauts communicate via radio. But NASA aims to establish a lunar communication system capable of supporting high-resolution video. Effective communication during space missions is as crucial as food and water, and with this new lunar 4G technology, video calls on the moon could soon become a reality. Plus, thanks to lunar 4G, we'll be able to track how the endangered species sent to the moon are doing. Oh, sorry, I completely forgot to mention something important. As more species edge closer to extinction today, scientists are collecting samples from animals, plants, and other organisms to store in biorepositories around the globe. Unfortunately, the conditions on Earth are far from ideal for these modern-day Noah's Arks. Hence, the decision to build 1 or 2 vaults on the moon makes perfect sense. On the moon, there's a permanently shadowed region at its south pole. It may seem like a fortunate coincidence, but some lunar craters may meet the criterion of temperature, -320 degrees Fahrenheit, which is precisely what we need for long-term self-storage. Initially, the plan was to construct the vault in lava tubes that run beneath the moon's surface, but that would have posed significant risks. This design requires a special solar-powered cooling system, and any accidental loss of power could be catastrophic, resulting in the destruction of all the samples. However, if we built it in a forever frozen shadowed area, the vault wouldn't need any energy or human maintenance. Bingo! It sounds almost too good to be true, and indeed there are several complications. For instance, dust is an omnipresent issue on the moon, infiltrating everything. If the storage requires seals, a dust mitigation system must be developed, which has not yet been created. So for now, it remains a theoretical concept rather than a practical solution.
40, 50 feet, why don't you turn around and let them get a view from there and...
I know you want to learn about real things, not just concepts. Here's something real for you. The moon is full of human waste, carefully packed into bags. According to estimates, there are around 96 of these bags you'd probably prefer to never open. But you never know what exactly is hidden inside. It could be any product of the human body out there. So, if we ever make it to the moon and you accidentally stumble upon a mysterious bag, my advice is to resist the urge to open it. Instead, you can hand it over to scientists. They say they're eager to get their hands on them. Humans are incredible, in a rather unfortunate way. We haven't even established a proper settlement on the moon yet, but there's already around 200 tons of junk scattered about. It piles up there as if it were a teenager's room rather than a celestial body. Alongside those rather unappealing human waste bags, you'll also find cameras, drills, towels, brushes, rakes, a multitude of other technical items, and surprisingly, a falcon's feather. I'll explain that in a moment. At the end of Apollo 15's final moonwalk, David Scott pulled out a falcon's feather and a hammer to demonstrate Galileo's theory that in the absence of air resistance, different objects fall at the same rate. Amidst all that junk, there's an actual piece of art, so we could say that the moon, if it doesn't have the very first art museum, at least boasts a small exhibition. The crew of Apollo 15 took a 3.5-inch tall aluminum figure to the moon. Created by a Belgian artist, it's called the Fallen Astronaut, and it was laid on its side with a plaque listing the names of astronauts and cosmonauts who contributed to exploration. But the list of odd objects on the moon doesn't end there. If you ever find yourself in need of cash, you can find it on the moon, since a stack of $2 bills was simply forgotten there. Yep, a lot of material has been collected since 1969, when humans first stepped on the moon.
It's one small step for man, one giant leap for mankind.
Our natural satellite was first seen in a telescope in 1609. But what about its true age? To understand that, we need to start with how the moon first formed. Back in the mid-80s, a conference in Hawaii brought together a bunch of scientists to figure out where the moon came from. They came up with a pretty cool idea. The moon probably formed with the stuff that our planet Earth donated. Picture this. A Mars-sized object crashed into the early Earth, flinging molten materials into space, which eventually came together to become the moon we see today. This theory clears up a lot of mysteries. For instance, it used to baffle folks why the moon has such a small iron core. The answer is simple. It formed from Earth's outer layer, which isn't rich in iron. And that pale crust of the moon? It's just minerals that floated to the top when the molten moon cooled down. At first, the moon was super close to Earth, but it's been slowly drifting away at about 2 inches a year, even while you're watching this video. Figuring out when this all went down, though, is a bit tricky. The Apollo astronauts brought back a bunch of moon rocks, which helped scientists estimate their ages. The oldest ones are around 4.35 billion years old, which is about 200 million years after the solar system kicked off. So, here's the thing. There's no exact date for when the moon formed, but there are several interesting theories. One idea is that the age of these rocks could mean the moon is around 4.35 billion years old. But some scientists who look at how planets form think that most of the material in the early solar system came together way before that 200 million year mark. They argue that a big impact that created the moon happening that late seems pretty unlikely, which means the moon could actually be older than 3.5 billion years. Another interesting thought is that the moon might have gone through some serious heating events as it moved away from Earth. This is similar to what happens on Io, one of Jupiter's supervolcanic moons. The gravitational pull from a bigger body can stretch and compress a smaller one, generating heat, like when you squeeze a rubber ball. The rocks on both Io and the moon warm up this way. Rocks have radioactive elements that act like internal clocks, helping scientists figure out their ages. The catch is, if the moon heats up too much, it resets those clocks and only starts keeping time again once it cools down. So those rocks that are about 4.35 billion years old might not actually mark the moon's birthday. They could just indicate a time of tidal heating. This suggests, once again, that the moon had to have formed even earlier than that.
A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the Sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the Earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO-Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO-Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the 4th imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was all right did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July, 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February, 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden, when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrowband radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origin satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called Mission Control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all sciencey. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the big crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first?
It's raining cats and dogs, literally. Things falling down from the sky can be pretty unexpected. So, here are some examples. Residents of Texarkana, Texas, once had light rain and fish shower. No need to go fishing out in the sea. The fish literally falls down on your head. In fact, animal rains are not uncommon. Water spouts or updrafts occurring in different corners of the earth sometimes carry small creatures up with them. Those could be crabs, frogs, or indeed, fish. A water spout is generally a whirlwind that picks up water and grows in size until it connects the surface of the water and the clouds. Lightweight critters living close to the water surface often get caught in the vortex and carried up and away. Thunderstorm clouds are constant companions of water spouts too. When the storm reaches a landmass, it starts slowing down, having nowhere to take the new energy from. It slowly subsides, the atmospheric pressure drops, and the thunderclouds release the water in them, along with the unfortunate small animals and fish. Sometimes it's just a few frogs frozen from the cold up above, but at other times it could be hundreds or thousands of creatures raining down upon the land. A much more unusual rain once happened in Oakville, Washington, and it's still waiting for someone to explain it. The rain clouds looked perfectly normal, but the rain they released was anything but. Translucent jelly-like blobs fell on the town, covering a total area of about 20 square miles. Each of them wasn't larger than a grain of rice. Researchers who studied these raindrops claimed that the gooey blobs contained human white blood cells. Some believe they might have been evaporated jellyfish, resulting in rain, or waste from a commercial airplane. Now this kind of rain is what I'd like to see someday, a money shower. One such event occurred in a small town in Germany. A woman was driving when she suddenly saw banknotes swirling down from the sky, so she hit the brakes. She went out of her car and later said she managed to collect quite a large amount of money, after which, as any responsible citizen should, she turned it over to the police. Strangely, when the officers came back to the scene with the woman, they couldn't find any more cash, although she claimed she hadn't been able to collect everything. There's still no explanation for the event, but certainly no water spout could have caused that. A pretty unpleasant kind of rain happened back in 1876 in Olympia Springs, Kentucky. It was a very local kind, too. Mrs. Crouch said that she had been making soap outside her home when pieces of raw meat suddenly started falling down from the sky around her. Some of those chunks were pretty massive, reaching over 3 inches in diameter. Local newspapers reported that 2 people who decided to remain unknown tasted the meat and concluded it was mutton or venison. Months later, scientists decided to find out the truth behind the strange event. It became a matter of heated debate until one of the researchers came up with the most reasonable conclusion. The meat rain must have been caused by vultures flying over the town at the time. These birds sometimes regurgitate food right in the middle of their flight as a defense mechanism, or to make their bodies lighter to fly faster. And that must have been what happened right over Mrs. Crouch's house, unfortunately. Something totally inedible, but no less sinister, rained down on several villages in India in the middle of May of 2022. Huge black and silver metal balls started dropping from the sky, the first one weighing over 15 pounds. Astounded residents watched in shock as it hammered the ground, scattering pieces of itself across the nearby fields. Similar balls later fell in the other 2 neighboring villages. Luckily, no one was harmed during the strange metal rain, but the issue remained. We're on Earth, and it usually rains water here. The local authorities weren't sure what it was about, but astronomers soon voiced a theory that it could be debris from a space rocket. One that fits the description had launched in September of 2021, aiming to put a communications satellite into orbit. Upon its re-entry into the atmosphere, it might have been damaged, causing several chunks of it to detach and fall down on the ground in India. Sometimes it rains birds, too. One such event occurred in Arkansas in 2010. Weather conditions might cause things like that to happen, but there are simpler reasons too. Loud noise and confusion, or even collisions with aircraft. In the case of Arkansas, it was the noise and flashing lights from the New Year's Eve fireworks. The show startled thousands of birds and made them start into the air. They were panicking and disoriented, so they collided with buildings, cars, and trees. Many of them eventually fell to the ground, making lots of people believe it was actually raining birds. Now, if anything could startle me out in the sky, it's a rain of spiders. And if you wonder whether it's a real thing, well, yes, it is. In Australia, spider rains actually happen quite often. They even have a name for this: ballooning. It goes like this. Spiders that can balloon climb up trees and tall bushes, trying to reach the highest point available in the area. When they've climbed up to the very top, they spin their web in such a way that it allows them to be carried by the wind. And there it goes, clutching the strands of the web with its tiny little feet. The brave spider lifts off into the air and flies to whatever awaits it out there. Normally, ballooning goes unnoticed by us humans because spiders don't travel in large groups. You might have a shocking experience when a spider suddenly lands on your face out of nowhere, but otherwise, it's a rare occasion to meet more than 2 ballooners at once. Still, when the weather gets particularly bad, with lots of rain or wind, thousands or even millions of spiders might decide it's time to move to somewhere friendlier and take to the sky all at once. That's when spider rains occur. Those who witnessed the most recent ones back in 2012 and 2015 say it looks like a snowfall. Spiders slowly drifting down on their web parachutes that settle on the ground and turn it white. Remember waterspouts? Well, those things can lift not only fish and frogs into the sky and make a spectacular show of them falling back on the ground. Golf balls sometimes become their cargo too. And I'm not speaking of golf ball-sized hail, but actual balls. The town of Punta Gorda in Florida witnessed a rain of golf balls in 1969. Newspapers reported dozens upon dozens of those things pummeling the ground and buildings for a short while. Since it's a coastal town with lots of golf courses, it wasn't hard to explain the event. A waterspout must have formed near the shore, traveled to some course, grabbed a few dozen golf balls, and then released them over the town. Rain can be pretty refreshing, as long as it's not mud rain. On April 12, 1902, the town of Easton, Philadelphia experienced an unusual shower. It made all those unfortunate enough to go outside take an actual shower and wash their clothes to boot. The raindrops looked dirty to the eye, and they were. People, buildings, and streets looked really wanting to take a good bath after it stopped pouring. The witnesses reported a considerable amount of dust in the air before the rain started, which probably explains the event. In 2011, a town in Scotland saw another weird rain variety. It was showered with worms. The rain didn't cover a large area. It seems only some local academy students were unlucky enough to get invertebrates falling on their heads while playing soccer. There was a significant change in the weather at the time, so scientists believe it might have resulted from some meteorological anomaly.
Venus has exceptionally high temperatures, hot enough to melt lead. It's the hottest planet in our solar system, with a high-pressure environment and super strong winds. The winds there are 50 times faster than the planet's rotation. It's getting stronger over time, and scientists don't know why. But they did find something interesting in the planet's clouds, a potential sign of decaying biological matter. Could there be life then? Not quite, since Venus has a dry, windy atmosphere and doesn't have enough water for life to develop. Rings around other planets are more common than we thought. Saturn's rings are the most famous and spectacular ones. They partially consist of reflective, sparkly water ice, and you can't see anything like that in the rest of our solar system. Jupiter, Uranus, and Neptune have ring systems too, and those most likely consist of dust and rocky particles. And not just planets. Astronomers found out rings were around one asteroid as well. Speaking of rings, why do you think that Earth doesn't have them? Gas giants have rings, while the rocky ones don't. Two theories explain how rings form. They could be the remains from the times when planets were forming, or they could be leftover material of an impact that destroyed an unknown moon, or gravity broke apart this moon of its parent planet. It's not clear why only the gas planets have rings. They formed in the outer area of our solar system, while rocky planets only in its inner circles. May be a good clue. Maybe these inner rocky planets had just better protection from strong impacts that could have formed rings. Also, there are more moons in the outer solar system, and there are more rings there. Another thing may be that bigger planets have a bigger volume, so a ring system can remain stable there. Some theories even say that Earth used to have a ring system. A long time ago, our planet collided with a Mars-sized object, which most likely resulted in a dense ring of particles and debris. But our story was a bit different than the outer planets, and those rings probably combined and formed the Moon. Do we know the shape of the universe? Einstein had a theory of general relativity. It said that the universe could be in one of these three forms: closed like a sphere, open like a saddle, or flat like a piece of paper. Its shape determines whether it's infinite or not, and whether it will expand forever or maybe collapse at some point. The shape of the universe depends on its density and rate of expansion. One of the best ways to determine its shape is to use something called the cosmic microwave background. It's the relic afterglow, something that's left of the Big Bang. Sound waves that were moving through the universe in its early stages produced quite small spatial variations in the temperature of its faint light. The result of these studies showed that the universe probably expands in all directions, which means it's flat. How come our sun is hot while the moon is cold? The sun gives off heat because its core is extremely hot. In there, the pressure is pretty high. The hydrogen turns into helium. That's how the sun creates light and heat. The solar light and heat are enough to light up our days on Earth, as well as support life here, even though the sun is around 93 million miles away from us. The moon is not hot because it doesn't have an atmosphere, so it can't absorb sunlight as our planet does. Its surface gets very hot in the daytime, about 210 degrees Fahrenheit, but since there's no atmosphere, the temperature drops extremely during the night to negative 279 degrees Fahrenheit. The sun is hot, no doubt there, but the space around it is very cold. Heat is the energy objects store inside of it. Temperature is how we measure if something is hot or cold. So when you transfer heat to certain objects, its temperature goes up. Take it away, and the temperature goes down. You can transfer heat in 3 different ways: convection, conduction, and radiation. Convection works within gases and liquids, and conduction is for solids. The temperature only affects matter. Space doesn't have enough particles. It's nearly a complete vacuum, which means transferring heat is not effective. The only way to do it is through radiation. When the heat coming from the sun falls on an object in the form of radiation, the atoms that make up that object will absorb energy. This energy moves the atoms and makes them produce heat throughout this process. In space, temperatures of the objects stay the same for a long time. Cold objects stay cold, and hot ones stay hot. If you place anything outside of the Earth's atmosphere and expose it to direct sunlight, the sun will heat it to about 250 degrees Fahrenheit. Objects in outer space that surround our planet and don't receive sunlight directly are at 50 degrees Fahrenheit. The temperature is like this because there are molecules that escape our atmosphere, so the sun heats them. We used to think that water was really rare in space, but now we know there's water ice across our entire solar system. For starters, you can usually find water on asteroids and comets. It's also in craters on Mercury and the Moon that are in permanent shadows. On Mars, you'd find ice at its poles, under the surface dust and in frost. It might not be enough to support human colonies up there, but it's still something. Some other bodies in our solar system also contain ice, like the dwarf planet Ceres and one of Saturn's moons. Europa, one of Jupiter's moons, could be one of the most likely candidates we know about that could contain life. It probably has an entire ocean under its frozen and cracked surface. It could have twice as much water as all oceans on our planet together. Titan, the biggest of Saturn's moons, also has a liquid cycle, but it's not water. Its cycle moves materials between the surface and the atmosphere. At first, it sounds like the water cycle we have on Earth. But immense lakes on Titan are filled with ethane and methane. There's a chance they're over a layer of water. Neptune is about 30 times as far from the Sun as we are. Of course, it gets significantly less light and heat than Earth, but it also radiates way more heat than it's generating. There are more things happening in its atmosphere, especially if you compare it to its neighbor, Uranus. Uranus is closer to the Sun, but it still radiates the same amount of heat as Neptune. The winds on Neptune are insanely strong, 1,500 miles per hour. No one still knows why. It could be a gravitational contraction, energy coming from its core, or the Sun. I hope we'll eventually find out. Can you imagine hot ice? It exists just 33 light-years away from us, on one exoplanet. This planet consists of different water elements and they form burning ice. The ice there is solid because of pressure, but the surface temperatures are extreme and go up to 570 degrees Fahrenheit. That's how the water stays super hot and comes off as steam. Picture putting ice in your coffee when you want to heat it up. When you stargaze, it's almost like you're looking into the past. Stars are really far away, and it takes longer for their light to reach our planet. So it's possible some of them have already run out of fuel and aren't alive anymore. The Pillars of Creation are a good example. This is part of a region 7,000 light-years away from us called the Eagle Nebula. These are clouds of gas and dust in the shape of pillars. Scientists first discovered it in 1995, but in reality, a supernova explosion destroyed these pillars that were at least 6,000 years ago. So, the 1995 image shows these pillars from 7,000 years ago. Mars has the biggest volcano in the solar system that we know of so far. It's bigger than the whole state of Hawaii, and 100 times larger than the biggest volcano on Earth. The red planet seems so quiet, but once upon a time, large volcanoes dominated its surface. Volcanoes on the red planet can probably grow so big because gravity there is a lot weaker than down on Earth. Also, the crust on our planet is moving all the time, and the Martian crust probably stays still.
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has two moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of two parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Mars quakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
Our moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the moon's poles, especially the South Pole, you'd see such shadows all over the place, 15,000 square miles of them. There are tiny cold traps that are only 0.4 inches wide, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny. But still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the moon. One theory says 15,500 square miles of the lunar surface could have the capacity to store water. But no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue. Highland regions are yellowish, with faint traces of pale and pink. Colors are not the same everywhere because of different amounts of various metals that are present on the moon, like titanium or iron in the surface minerals. Our eyes are not sensitive enough to pick out such differences from this distance, but the majority of the lunar surface consists of minerals that are naturally gray, and that's mostly the color we see from our planet. When you're in space, you can't walk on the ground. No gravity, so no need to wear shoes. That's why astronauts mostly wear socks, or eventually add another warmer pair if they're cold. But something strange might happen to your feet while you're up there. First, if you have calluses, they may fall off after some time. One astronaut described his experience and said the bottoms of his feet became very soft, while the skin on the top of his feet became very rough, like alligator skin. He engaged the top of his feet to get around when he was using foot rails on a space station where they stay. It's not easy up there. Astronauts on the International Space Station, ISS, have to use foot rails and loops to remain steady. When they have to do regular things, like just getting a haircut. When they want to do training, they can strap their feet into sneakers on the exercise equipment. It's essential for them to exercise way more than they'd have to on Earth, around 2 hours each day, because the human body isn't used to moving or performing any actions we normally do without gravity that kinda holds us together. Plus, if you stay in space for a longer time, you can lose much of your bone and muscle mass. For example, you can lose almost 20% of your muscle mass if you spend only 11 days in zero gravity conditions. But if you were up there, there's no point in using weights, right? Zero gravity affects them too. Instead, astronauts mostly use a device outfitted with 2 small canisters that create a vacuum and allow them to pull against a long bar. On the ISS, you can also use a bike and a treadmill. Did you know that NASA spent millions of dollars developing a pen that you could write with in zero gravity? A pencil is not the best solution for space travel. They have a habit of breaking and shattering, which can leave graphite dust behind. Also, they're wooden, which brings a high risk of fire in the pressurized, oxygen-rich capsule. That's why even such an everyday thing as a pencil can be life-threatening in space. So, they had to develop the space pen. It writes crisp and clean and can't rely on gravity to make the ink flow. Instead, it uses compressed nitrogen to force ink out of the nozzle. This way, you can write while you're floating upside down or even submerged underwater. Even when they're up in space, astronauts still face everyday things, like that unpleasant itching sensation on their faces. They can't just satisfy it while in their spacesuit. They need to improvise, so sometimes they scratch the spot with a microphone attached inside of their helmet. Sometimes they attach patches of Velcro inside their helmet for such things. One of the most complicated issues with space trips is how to protect astronauts from space radiation. Our body has not evolved to handle proton storms and cosmic rays coming from the sun. Of course, spacesuits and the rest of the equipment are essential. Some research also showed an antioxidant-rich diet that usually includes a bunch of vegetables like spinach, tomatoes, and beetroot is promising. when it comes to reducing the bad effects of radiation. Astronauts didn't always wear white spacesuits. During NASA's first manned spaceflight project, called Project Mercury, they had silver suits. But none of the astronauts went out and explored the vacuum of space back then. Silver is not a good color for that, because spacesuits have to be highly reflective. White is the best for that. That color is the most effective for reflecting radiation while in outer space. We're on Earth, which means the atmosphere is like a shield that protects us from 77% of radiation coming from the sun. But astronauts don't have such protection up there, and this means they're very vulnerable to severe sunburn and extremely high temperatures. A white spacesuit helps, the same way as white paint on your walls helps you keep an entire room cooler. A lighter color will absorb 35% less heat. White is not the only color in their closet. When heading into space or coming to Earth, they sometimes wear a bright orange suit. It's a color that attracts attention. So if anything goes wrong during landing and astronauts have to quickly leave their ship, the rescue crew will spot them more easily. But times are changing. So today, we have more sophisticated tools to locate astronauts that need help, such as GPS trackers and transponders, so suits don't have to be orange anymore. Floating through space. Everything's peaceful, and you're enjoying the magnificent view of the dark and quiet infinity filled with billions of stars, planets, comets, suns, moons, and so many other things we'll probably never even discover. 95% of our universe still remains a mystery to us. But at least the view is awesome. But it's only good if you're tethered. What if something goes wrong on your spacewalk and you detach? The whole scene goes from a beautiful dream to a nightmare in a second. But don't worry. NASA has designed a special jetpack called SAFER, Simplified Aid for EVA Rescue. It fires compressed nitrogen from 24 thrusters, which is how it can steer the astronaut back to safety. In theory, you could vent some gas from your suit too, or maybe throw a tool in the opposite direction, which is how you'll push yourself forward. But it's tricky because you'd need to throw it precisely in line with your center of mass. Otherwise, you'll just start uncontrollably spinning, and before you know it, you'll become so disoriented you'll have no idea where to go, even if you could. But SAFER will automatically detect rotation and use its jets to help you stay oriented towards the safe spot. It took scientists 10 days to teach a goldfish to drive a car. They taught it to move its own tank towards a certain target, and in return, the fish gets a treat. This research could help us navigate through space one day. There has to be some mapping happening in our minds. That's how we potentially link our body parts and movements to changes we go through when we're in space. That's how we'll know how far we can extend our arm to reach for a cup of coffee without going too far and knocking the coffee over. The movement control is not the same as under the force of gravity, and we need to be sure if such maps in our brain differ between sea and land, or if it's something universal. So when I say scientists taught a fish to drive, that basically means if the fish saw a target, it should touch the wall of the tank facing the desired direction. That way, scientists could guide the wheels and move them where the fish wanted to go. Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet, 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there will be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sunshield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
They say somewhere out there, there's a pen that can work in zero gravity, at extreme temperatures, and even underwater. They say this pen can write on almost any surface, or if you turn it upside down, or when your surroundings are heated up to 570 degrees Fahrenheit. They say NASA spent millions, or probably billions of dollars, and almost a decade to develop such a pen. The problem with ballpoint pens in space is that they don't work in the conditions of weightlessness. The ink can't flow to the ball normally since gravity doesn't affect it. Instead, pressure is created in the ink reservoir and pens start leaking. Some time ago, NASA used pencils, but wooden pencils were considered to be a fire hazard in most spaceships. All because, at that time, the atmosphere inside them was 100% oxygen. The need for a super pen was obvious. But whatever the rumors claim, NASA did not create such a pen, spending a fortune on the research. Its development was sponsored by Paul C. Fisher of the Fisher Pen Company based in Chicago. He spent over $1 million and almost 10 years to make a pressurized ink cartridge. It was supposed to allow space pens to function in zero gravity and other extreme conditions. Eventually, they got a pen that could write at a temperature of -30 to 250 degrees Fahrenheit, which is really impressive, isn't it? The pen was patented in 1966. And 1 year later, after conducting several thorough tests, NASA started to provide Apollo astronauts with such pens. Interestingly, the rumors about NASA spending an insane amount of money on the development of space pens have been circulating for decades. They have been debunked many times, but they appear again and again. Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of a sound effect, which is a totally false misconception. In space, no one will hear you scream. You know why? There's no air in space. It's an almost perfect vacuum. And sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Here's another one. All comets have beautiful long tails. It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. Now, let's look at a light year. This very notion makes us believe we speak about time here. But in reality, light years measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. Hey, do the math. Now, people often believe that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth, and the Sun doesn't float away from our home Milky Way galaxy. But the astronauts on the ISS experience not full-fledged, but microgravity, which means very small gravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Now, it may seem as if the sun is always on fire. At least that's what it looks like in pictures. But in reality, our star is a giant ball of gas. Hey, I can relate. Nuclear reactions happening in its core at all times makes the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat. But it's not actually on fire, because no oxygen is involved in the process. A human can explode if they get into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk won't be as dramatic as it's often pictured in movies. A person will lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. Before it happens, the person should breathe out as much air as possible. Otherwise, this oxygen will damage their lungs from the inside. Then, without the protection of the spacesuit, which is like a mini spaceship, the pressure inside their body will drop. This will cause even more serious troubles. And even though this person definitely won't burst, they won't want to stay outside for too long. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star comes too close does a black hole spring into action. Even so, only those space objects that cross a certain border get ripped apart. If the Sun were suddenly replaced with a black hole, Earth's orbit wouldn't change. At the same time, Earth's temperature would be different. There would be no solar wind, and no magnetic storms created by the Sun would affect our planet. And let's say the black hole that replaced the Sun had the same mass as our star. Then, according to the law of physics, Earth would have to come very close to get pulled into this black hole. Now, the dark side of the moon myth was debunked more than 50 years ago. And still, not everyone knows that this dark side is simply part of the Earth's natural satellite that faces away from our planet. By no means is it darker than any other region of the moon, and sunlight falls equally on all sides of the satellite. It only seems dark because we never see this side of the moon from Earth, all because of the phenomenon known as tidal locking. Over billions of years, let me say that again, billions of years, the gravitational connection between our planet and its natural satellite has changed their orbits. The speed at which they move has also become different. And since Earth is way bigger than the Moon, the satellite's rotation was gradually slowing down, until at one point it reached the point of balance. And now, it takes the Moon the same time to make a full rotation around its axis and to fully orbit around Earth. Now, you might have heard people referring to Venus as Earth's twin. It's true that both these planets are of almost the same size. They have similar mass and composition. The surface gravity on Venus is 91% of that on Earth. So, if your weight was 100 pounds on our planet, on Venus you'd weigh 91 pounds. And still, calling these planets twins is a step too far. The atmosphere on Venus is 100 times thicker than that on Earth. Plus, its surface temperatures are insanely high, up to 850 degrees Fahrenheit. That's hot enough to melt lead or burn up your pizza. Venus has no water oceans or any life forms. It also rotates backward compared to all other planets of the solar system, including Earth. By the way, another myth claims that Mercury is the hottest planet in the solar system. After all, it's the closest planet to the Sun, but Venus is actually hotter. Asteroids strike Earth much more often than people tend to believe. But most of these collisions aren't history-changing extinction events. Most of them go completely unnoticed. Most asteroids that approach our planet are qualified as small, near-Earth objects. They usually burn up in Earth's atmosphere before they even have a chance to wipe out life off the surface of the planet. Not that they're big enough to do that. And still, around 40 to 80 tons of space debris fall on Earth every year. Most of this debris is tiny asteroids, also called bolides. They're usually no larger than 65 feet in diameter. That's small? Yeah, says so right here. Okay. Spacesuits are made of many different materials, elements, and functioning mechanisms for them to protect you in the vacuum of space. Good thing. The freezing temperatures and lack of oxygen aren't suitable for any living being to float around without any sort of protection on, not to mention the burning sun rays and potential objects that can crash into you. The technical term for a spacesuit is extravehicular mobility units, and they're extremely durable and expensive to make, with each suit costing up to $10.4 million to make. Each spacesuit is custom-made, with each part and component created and manufactured by 80 different companies. The size of each piece may vary, so it can either fit in the palm of your hand or be as large as 30 inches. The suit has 18 separate items and 16 layers covering it. Well, in reality, there are 14, but if the 2 internal layers are added, it will be 16 in total, so there. Spacesuits have evolved over the decades to be the design it is today, a mini spaceship in human form. It's built to mimic the living conditions of Earth's atmosphere, so that the astronauts can't be exposed to space. It has a system to support oxygen and expel carbon dioxide. It's durable enough to protect the astronauts from solar radiation, harsh sunlight, and little micrometeoroids. The conditions inside our atmosphere can be extremely tough, which is why it has internal temperature control for the bodies and a pressurized enclosure. The temperatures outside the suit can be as hot as 250 degrees Fahrenheit, ouch, to minus 250 degrees. Brr. It's designed to support life or anyone outside our atmosphere. The main piece of the suit is a cooling garment made out of nylon, stretchy spandex fibers, and liquid tubes. It's delicately designed to fit around 300 feet of tubes woven tightly together in clothing that occupies the whole body, except the head, feet, and hands. It uses chilled water to flow through the many tubes near the skin to regulate the body temperature and cool it down while spacewalking. Think of it like a fan in a laptop that's made to cool it down when it overheats. The whole garment is attached to the life support system. Now, the life support system is one of the most important pieces of the suit and requires meticulous effort to put together. Everything in this compartment is important to keep the astronaut alive in space. Any miscalculation can be devastating and even life-threatening. It houses the pressurized oxygen tanks when they're filled and sealed tight. The oxygen tank can provide up to 7 hours of fresh air to breathe. There's also a secondary tank that adds around 30 minutes of breathing time. Astronauts can't afford to waste oxygen all the time while wearing the suit, so it's important that they strategically allocate those breaths. There's also the carbon dioxide removal device, which includes a filter canister made of lithium hydroxide that's also attached to a tube. That way, there won't be any toxic carbon dioxide circulating inside of the headpiece, and it will always purify the air inside. Next to it is a ventilation fan to cool the astronaut when moving. Wearing a heavy suit isn't easy and requires a lot of physical effort to move. Even though gravity is weaker up there, you still have to move your arms and legs, which can be tiresome over time. There's also a source of electrical power and a two-way radio to communicate with the base. And just in case something happens, a warning system is installed to warn the astronaut of failures in the system. Uh-oh. Finally, there's the water cooling equipment to keep the body cool and regulated. After the life support system is put together, it's attached to the hard upper torso part. The helmet on spacesuits, built for spacewalks, serves as a pressure bubble and is made of strong plastic to keep the pressure of the suit contained. There's a neck ring to keep it airlocked in place and a ventilation system to provide oxygen to the astronaut. And there's also a connection to a backup oxygen tank, just in case. While the astronauts are working in space, they might crave a little bit of water or something. Good thing there's a built-in straw for them to drink from. And also, while working in open space, there's that annoying sun that shines into your eyes. A visor is installed to protect the astronaut from the sun that's made of a gold coating. And what's a spacesuit helmet without a camera to record everything? Since the two-way radio is connected to the life support system, the headphones and microphone are placed in the chin strap where the astronaut can communicate with the base. Space can be dark at times, most of the time. So there's an inbuilt light bar used when operating on close-up objects. Continuing our space fashion show gala, over at the lower torso unit, we have the pants and boots area. There's also a knee to ankle and waist connection, comprising of a pressure bladder and a specially coated nylon. Most of it is made out of different elements and materials to keep it usable and durable in space missions, as well as providing stylish evening wear for that astronaut who goes out at night. You can adjust the size of the rings of the thigh and leg sections whenever you want. This is good when the astronaut is walking and needs to feel relaxed at certain times. The astronaut also wears thermal socks under the hiking-style boots, which have a heat retention system built in to keep those tootsies warm and cozy. The upper torso is hard yet lightweight. It's made out of metal and fiberglass, connecting the inside of the suit to the life support system. It resembles a t-shirt but attaches to the arm assembly, which stretches to the arms up over the wrist. There's also a special connection to the helmet ring piece. Over here, you can find water reservoir tanks, oxygen cans, and much other technical stuff needed for outer space. The newer spacesuits have a hatch in the back for the astronauts to climb in and enter the suit. How stylish! A control module in the chest area allows the astronaut to check up on the external conditions and monitor the fluids and electricity. The gloves are sturdy enough to protect the astronauts when touching and picking up objects while working outside the space station. They're built so well that they can move each finger with ease. They're the part of the body that gets cold fast in space, so the gloves have a heater system to keep them warm. The process of creating a spacesuit requires so many steps and details, so it's not like sewing together a sweater. It starts with a design integration and then modeling. That way, they can see what it looks like without gathering the materials to build it. And once the design is confirmed, they begin gathering all the materials, which can take some time. And when everything is gathered, they begin the fabrication and building, which can also take time. A total of 7 different parts will be created and shipped to NASA for assembly. When an astronaut goes outside the International Space Station, they must have a safety strap attached to them that connects to the station. That way, they won't float away while doing some maintenance work. The longest spacewalk lasted a total of 8 hours and 56 minutes, and the suits have come a long way. During the Apollo 11 mission, Neil Armstrong couldn't walk on the moon properly, even though, technically, he was the first to walk on the moon. He actually did some bunny hops. But with the newer innovations and technologies, astronauts can walk and turn their hips in space. NASA plans on going back to the moon by 2024 and is preparing 2 new spacesuits with better technology and dexterity. It's called the Z-Move, and it's based on the current design of what astronauts wear on the International Space Station. But the new designs and features will allow humans to live and work on the moon. A demonstration showed how flexible it is compared to the previous ones. You can twist and bend at the waist. The legwear section is better for walking on the moon's surface. Minor changes include no zippers or cables to keep out the dust.
Picture this. You're an astronaut, hurtling through the cosmos in your state-of-the-art spaceship. But suddenly, you notice that you're running out of fuel. What are you going to do? Trapped in the middle of space. It's hardly like there's a floating gas station. The good news is that you're not going to get completely stuck. A spaceship will never actually stop after running out of fuel, all because there's basically no atmosphere in space. That's where the popular phrase, "in space, no one can hear you scream," comes from. Sound travels through the vibration of teeny tiny atoms and molecules. In space, where there is no air, there's simply no way for sound to travel. It's the same for our spaceship. Because there's no air, there's also a complete lack of air resistance. Those tiny particles that do exist in space are way too small to reduce the spacecraft's momentum or drag it back. Because of this, most spacecraft actually turn their engines off for the biggest part of their journey. So, don't believe those movies that show spaceships with their engines on all the time. That's completely inaccurate. Unlike vessels in the water, a ship in space doesn't need constant thrust to keep moving forward. Usually, its engine is only fired up for short periods of time. This is not only practical, but also saves money. Fuel is really expensive to transport into space as it's heavy. That's why space probes try to use as little fuel as possible. They need it when they set off from Earth, and then again when they re-enter the atmosphere. It happens when they need to slow down upon their return. While cars and trains have brakes, it's not that simple to bring a spaceship to a screeching halt. The engines are needed to slow the ship down or bring it to a complete stop. This involves strategically firing up impressive thrusters at the front. It creates the needed drag and reduces the spaceship's speed. But this process also requires super high levels of precision. One wrong move and you're toast. Literally. Hit the thrusters too fast and the spacecraft will set on fire as you re-enter Earth's atmosphere at thousands of miles per hour. Traveling too slowly can also cause problems, because in this case, you might miss our planet's orbit completely and move way past Earth. And most spacecraft don't have enough fuel to try for a second re-entry, so traveling too slowly needs to be avoided at all costs. But back to the issue at hand. This basically means that any vehicle with an empty tank will continue traveling at the same speed across space until it eventually runs into something. There's just no other way for it to stop. Wait, actually, maybe that's not good news. If you get stranded, it's pretty unlikely that your buddies over there at NASA are going to organize a rescue mission. This sounds kinda sad, but it does make sense. By the time they set up a new team and find a ship to come and rescue you, you'll have already traveled so far into space it would take them years to reach you. This would also cost a ridiculous amount of money. NASA spends on average a whopping $152 million to launch a ship into space. That's as much as buying 6 brand new top-of-the-range Lamborghinis. Even crazier, it cost NASA about $49 billion to develop and launch the first space shuttle. Unfortunately, once you've left Earth's orbit, it's near impossible that you'll make it back without fuel. That's what actually happened to NASA's Dawn spacecraft back in 2018. On a random day, the spaceship ran out of fuel. This left it completely stranded in the middle of space. It stopped transmitting signals to Earth, bringing an end to an 11-year-long mission that set loads of space records. The spacecraft could no longer generate electricity, as it had no fuel to move its solar panels to point them toward the sun. And to this day, the spaceship is still floating somewhere in space in a derelict state. Luckily, Dawn had no astronauts on board. The spacecraft began to orbit the dwarf planet Ceres, which was the object it was originally investigating. For context, an orbit is a curved path around a star, planet, or moon that an object gets stuck in. But wait, NASA are experts in all things relating to spacecraft. So how did they allow a ship to run out of fuel in the first place? It's actually super difficult to accurately measure the amount of fuel you'll need in space. On Earth, gravity keeps all the fuel at the bottom of the tank, and you can use a float sensor to measure how full the tank is. But this is impossible in space due to a lack of gravity that normally weighs the fuel down. Instead, a common approach is to add an air bladder into the fuel tank that's pressurized before launch to push the fuel into lines. The more fuel is used, the more this bladder expands. It takes up more space and keeps the fuel under the right amount of pressure. This pressure is monitored. That's how they can tell how much fuel is left. As you see, it's a lot more complicated than here on Earth. But say there were astronauts aboard a spacecraft that had run out of fuel. How long could they survive? Well, this depends on how much food and water is on board. NASA usually calculates the extra amount of food astronauts need for their trip to avoid adding extra weight to the spacecraft. But the good news is that this food can technically be rationed, and its consumption can be spread out. That's because astronaut food comes in special packaging to stop it from going bad. There are no refrigerators aboard spacecraft. The food comes in clear, flexible pouches that can be snipped open with scissors. All the food is pre-cooked and processed, so it doesn't need to be stored in a fridge. The only exceptions are fresh fruit and vegetables. These are the only things that need to be eaten quickly, as they will spoil. Today, astronauts also work with nutritionists so they can pick out the foods that they like and will enjoy eating. They can choose from a whole bunch of products, including mushroom soup, macaroni and cheese, chicken, beef, ham, nuts, and even yummy cookies. Shrimp cocktail is apparently a new favorite among astronauts because of how spicy it tastes. Flavored drinks also come in powdered form, just like the Kool-Aid or instant coffee packets you have sitting in your kitchen cupboard. Interestingly, astronauts often report not feeling hungry in space, so it may be easier than you'd think to ration the food. But even if you can make your food last, what about water? Transporting anything into space costs a lot, and water is quite heavy, so it costs even more to transport. For this reason, tanks of water can't be constantly shipped up to space. Instead, astronauts have a really complex water system. It squeezes every last drop of safe and available liquid out of the environment. This involves recycling used water. It means that our buddies in space drink water that's been filtered from old shower water, their breath, the spaceship's fuel cells, sweat, and so on. But don't worry, such water is safe to drink, and it's actually even better than most drinking water that comes out of taps in the US. The water on a spacecraft first goes through a bunch of filters, starting with one that removes particles and debris. Then it passes through multi-filtration beds, containing clever substances that remove impurities. The final stage gets rid of harmful compounds and destroys nasty bacteria and viruses. There are also water reserves in case of emergency. For example, the International Space Station keeps around 530 gallons of water in its reserves, just in case. But what about the air supply? The primary source of oxygen on spacecraft comes from something called water electrolysis. This is an amazing system that uses electricity from the craft's solar panels to split water into hydrogen and oxygen gas. But as we saw with NASA's Dawn, without electricity, it's pretty difficult to aim the solar panels at the sun, which means that the oxygen system would likely shut down. There is some oxygen stored in a pressurized storage tank, though. This is a backup supply designed for emergencies, so it's not all bad news.
There's a giant ghostly hand that stretches across space. Its eerie fingers are reaching for a glowing red cloud that looks like molten space lava. Although it looks like a scene straight out of a sci-fi movie, it's 100% real. The hand was formed after an enormous star collapsed in a huge supernova explosion. The boom created a new star that is bursting with energy. The energy given off by the star is so big that it caused debris from the explosion to swirl around it. This is what created the supernatural-looking hand. The hand is so big that it stretches a colossal 150 light-years. As for the lava-like structure it's reaching for, that's actually a huge gas cloud. So, while it looks spooky, it's completely harmless, and you can go to sleep tonight without worrying about a giant ghostly space hand scooping you out of bed. There's a bizarre star hidden in the depths of space that seems to randomly flash on and off. It's known as Tabby's star, and its light dims at super irregular intervals for really odd lengths of time. There have been so many theories about what's causing this, from meteor showers to outer space interference. The comet shower idea was quickly debunked. Dust from comets, which would block the light, goes away after a couple of months. Tabby's star fades slowly over decades, so the timing just doesn't add up. It can't be down to planets either, as no planet is big enough to block that much light from a star. After years of speculation, scientists have finally found an explanation for the strange phenomenon. The dimming and brightening are actually a result of space dust. A ring of dust surrounds the star, which often temporarily blocks its light. On day 8 of its mission in 2019, China's Lunar rover discovered something really strange on the far side of our moon that caught the attention of the entire world. While navigating a path around a bunch of lunar craters, it spotted something really weird lurking inside one of the moon's holes. It was a colored substance, just like gel, that we'd never encountered before. The curious material was a rich dark green color and glistened like diamonds. After a year of analyzing the foreign substance that measured 20 inches by 6 inches, the scientists finally came to a conclusion. The glistening effect seems to come from glass. In space, it usually appears as a result of lunar impact melts. This means that it's most likely from a comet or rock that has hit the moon and melted upon impact. But while it's likely that the strange substance is just melted rock, scientists aren't 100% sure. This is because the pictures were captured under bad lighting conditions, and there were a bunch of other factors that badly impacted the quality of the images. So, the jury is still out on this one. There's a huge space cucumber floating through the galaxy, and no one really knows where it came from or why it's there. Okay, it's not exactly a cucumber, or a pickle. It's more likely a super elongated rock. Scientists think it may be longer than half a mile, but only 540 feet wide. It's traveling so quickly that there's no way it's bound by our sun's gravity, meaning that the strange object was formed somewhere outside of our solar system. We don't even know how long it's been wandering through space. It's estimated that it entered our solar system during the Victorian era, but who knows where it had traveled before then. For years, we've been told there are 8 planets in our solar system. 9 if you count Pluto, which got kicked out of the club some years ago. But that might all be about to change. There may be an enormous secret world lurking in the midst of our system, which scientists are calling Planet 9. This undiscovered planet could be way out past Neptune. There are seemingly unexplained clusters of orbits there, and this hidden 9th planet would explain this. The planet, if it exists, would be 10 times the size of Earth, take at least 10,000 years to orbit the Sun, and would sit over 200 times further out than our home planet. This is why it's been so tricky to identify, as it's almost impossible to take a picture of. In 2019, 30% of the area that the planet is likely to be in had been searched. It will take at least another 2 years to cover the remaining area. In the meantime, we'll be waiting on the edge of our seats. No. Strange radio waves are beaming down on Earth, and scientists are baffled. These fast radio bursts are sudden, unexplained, and last just milliseconds. We first picked up the weird signals in 2007, and scientists have been scratching their heads ever since. They appear to be coming from outside the Milky Way, millions of light years away. For us to pick them up from that far away, they must be emitting more energy in a fraction of a second than the Sun does in 80 years. Most of these signals only came once, which would have made identifying them much easier, until this all changed in 2017. In August, a signal was picked up that repeated 93 times, ruling out speculation that the signals were being caused by random one-off events. To this day, we still don't know what's causing the signals. Back in 2014, NASA captured a surprising picture of the Sun that showed that it might like to play dress-up. A brilliant storm of magnetic fields caused the Sun to look like a flaming jack-o'-lantern. Even weirder is that the image was captured on October 8th. It was possible because of something called active regions. These are basically areas of the sun that have greater levels of light and energy. This is what gives the flaming look in the images. The light forms two eyes, a nose, and a wide, jagged, smiling mouth. Fortunately, this look was just a coincidence, and there isn't a giant pumpkin carving enthusiast lurking in the depths of space. Hey, I want to know, is this a trick or treat? Space fans spotted what appeared to look like a spoon on the surface of Mars. It was half covered in dust. They noticed it after images from a Mars rover had been released. As spooky as the suspicious silverware may sound, it was just a trick of the light. The spoon is just a regular old rock, albeit in a slightly odd shape. The play of shadows in the photo made the object look even more spoon-like. Maybe there's a dish nearby that the spoon ran away with. A cosmic eyeball floating somewhere among the stars is no regular-sized eye. It measures an incredible 660 miles across. One of Saturn's moons, Tethys, has become a bit of a celeb to space fans. The spherical moon sports a large crater that makes it look exactly like a giant interplanetary eyeball. There's even a set of peaks inside the crater that look like an iris. Saturn has a gang of 60 moons in total, and Tethys isn't the only one that looks like a random Earth object. Prometheus looks like a potato, Atlas resembles a pita bread freshly served from a Greek restaurant, and Mimas even looks like some villain's spacecraft. And then there's this. There's a giant cat's eye right in the middle of space. Its official name is NGC 6543, but that's kind of long and boring, so most people call it the Cat's Eye Nebula. And it's actually one of the first nebulas to have ever been discovered. Like other nebulas, it was formed by a star that shed its outer layer of gas. The gas floated off and produced this amazing and intriguing structure. The star fires off this layer of gas every 1,500 years. Each time it does this, it creates a spectacular new dust shell. Hey, don't get me started on gas. So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So, if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort, rather significant to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than our Sun. Their event horizon is wide, and gravity doesn't change as quickly. So the force you'll feel at your heels and at the top of your head will be about the same, and you can go all the way to the heart of the black hole. This myth is busted. The next myth claims we can save the Earth from a giant asteroid with a big bam. The familiar plot is that a spaceship lands on the surface of an asteroid. A team of astronauts quickly drills a hole in it, leaves a present there, and flies away. Then, bam! As a result, the asteroid may break into several pieces and continue on its way to Earth. Well, big chunks of the asteroid fall to our surface, causing a lot of damage. So, our mission is failed. Well, to save Earth, we need a really big bam. Not only outside the asteroid, but right above its surface. When the boom happens, the force of the blast pushes the asteroid slightly downward. Even a slight change in trajectory would be enough to make the asteroid fly past the Earth in the future. Done! Oh, and if you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yeah, we often hear the sound of spaceships and battle in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you. The sound wave begins to push the first air molecule next to the clap, then the third, fourth, and so on until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. One more myth about asteroids. We need to fly a little farther than Mars' orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid cloud. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the Moon, so there really aren't that many of them there. To understand the size of the emptiness in space, look at the collision of two galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Another myth is that there's zero gravity in our orbit. Imagine you're in a huge box 10 miles up in the air. Now we let go of the box and it starts to fall. You're falling simultaneously with the box at the same speed. And now it's as if you feel zero gravity. Well, the same thing happens in orbit. The International Space Station is 250 miles above the Earth, and it's falling continuously, though not on the surface of the planet, but around it in its orbit. Its speed at this point is about 4.7 miles per second. It could cross the United States from the west coast to the east coast in just 8 minutes. So the astronauts there are experiencing the same thing. They're just falling with the ISS at that speed. Now, let's look at the Moon. It always looks at us with one side. This means the Moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the Moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So, whenever you look at the Moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. One myth that turned out to be untrue is that people have never actually been on the Moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the Moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the Moon perfectly. The astronauts didn't grab them when they left the Moon. They left a lot of stuff there too. They even ripped out the armrests of the seats of the lunar module to reduce its weight. Now, the total weight of human trash on the Moon is about 187 tons, including several lunar rovers, spacecraft debris, rocket stages, and lunar probes. That's like 3 Boeing 737s. The next myth is about summer. The hot season comes because the Earth approaches the closest distance to the Sun in a year. The Sun warms our planet more, and we all have to go to the beach. Well, not true. Let's draw an axis through our planet. It's slightly tilted on one side, and winter comes when our planet's axis is tilted away from the Sun. But over time, the axis tilts toward the hot star. Then its rays shine at such an angle that it gets warmer. It's true, though, that the Earth happens to be at different distances from the Sun. This is because our orbit is not a perfect circle, but slightly flattened, an ellipse. Normally, we think of the distance to our star as about 93 million miles. But that distance may be longer or shorter than 3 million miles, depending on which point in our orbit we pass. Another myth about the Sun is that it's yellow. Well, let's send you into space for this one. You look out the window and it's white. The Sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our Sun. But young and very hot stars are bright blue. The Sun is about in the middle of the spectrum. You've also heard about how, if you take your spacesuit off in outer space, you'll blow up like a balloon. Well, our bodies are designed to function at atmospheric pressure, like outside. But space is a vacuum. Imagine a huge metal barrel, and we sucked all the air out from there. Add to that a temperature of minus 455 degrees Fahrenheit, and you have space. If you could get into those conditions, all the air pockets in our body, like our lungs, would start to expand. So you really could blow up like a balloon if it weren't for our elastic tissues. They stretch and bend, so you keep your body size. You'll have enough oxygen in your body to last about 20 seconds. Then your brain will begin to starve and soon you'll pass out. So you won't blow up, and you won't even freeze because you'll be in a vacuum. It doesn't conduct heat. For example, water conducts heat very well, and you feel cold from it instantly. But you feel better in the air of the same temperature. If you're in the vacuum of space, the super low temperature won't be a problem for you. Much worse is solar radiation. On Earth, we have a shield against radiation in the form of the atmosphere. It blocks the harmful rays. In outer space, you would be defenseless. Another myth is related to cell phones. People think that when you dial your friend's number, your phone sends a signal into space. There are a bunch of satellites out there that will pick up your signal and reflect it like a mirror right into your friend's home. No, not true. However, there are satellite phones in the world that work that way. But when you make a cell phone call, your signal is transmitted through a system of cell towers from one to another until it gets to your friend's phone.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
It's September 1977. You're playing one of the first video game consoles released in North America. You step outside and see the whole neighborhood waiting for Voyager 1 to launch. It's a super sunny day, so you squint a little, trying to see what's happening. You live in the neighborhood right outside the launching station. You get yourself some food and watch the Voyager take off into space. You're so impressed, you decide to dedicate your career to working with NASA. 35 years later, you're now a senior official in NASA, specializing in Voyager 1. It's 2012, and you're sitting in the control room with your colleagues. Everyone is staring at their computer screens as they work on the Voyager. You're sitting on the top, overlooking everything and making sure all systems are in check. This day is special, as Voyager 1 is about to exit the heliosphere, which is a science word for the outer shell of our solar system. It's a bubble of space affected by the solar wind, which comes from the sun. By 2021, it got 14 billion miles away from Earth, which is equivalent to 153 astronomical units from the sun. 1 astronomical unit is the distance between the sun and the Earth. The craft was originally meant to fly by Uranus, Saturn, and Jupiter, and toss itself from one planet to another with the use of their gravitational pull. Everyone is impatiently waiting for it to exit the heliosphere. 3, 2, 1, and it's officially out. All systems are normal and functioning. You praise your team for doing an excellent job. With Voyager 1 reaching this far, there's still tons to explore in outer space. You were once a young adult watching the craft launch outside your neighborhood, and now you're the main person in charge of the operation. 9 years later. Since Voyager 1 left the heliosphere, you've been checking up on it every now and then, making sure all systems and functions are in order. It's been sending back measurements of the interstellar medium. It's the area between the stars of our galaxy, consisting of ionized materials. Ionized is basically a simple version of a molecule or substance. The interstellar medium is an electrically charged state of plasma, or ionized plasma, and is very unstable. It's like going from lightning in a thunderstorm back to calm rain in a matter of seconds. The plasma up there is different than the plasma on Earth, in that it's difficult to filter out. There are around 0.06 atoms for every cubic inch in the interstellar medium. The air we breathe on Earth has billions of atoms. By measuring the plasma in the interstellar medium, we can further understand the behavior and structure of chemicals and gases. It's possible that the oxygen we know and love on Earth is different than the ones out there. One of your main tasks is to learn more about how the solar wind from the sun and interstellar medium interact with each other to create the heliosphere. So, after doing some routine checkups and other maintenance work on Voyager 1 from the control room, you notice something strange coming from the screen. You sit in front of the computer, crunching the numbers of the plasma vibrations and convert them into an audio file of about 3 kilohertz. You click on it and listen to an eerie, subtle hum. You and your team are surprised that these vibrations occurred in such a small frequency. Given that space is massive, something like this might mean life on other planets. Everyone else at the station rushes to the control room to listen to that sound from outer space. It's monotonous and faint, but it's definitely coming from outside the heliosphere. You run the numbers over and over to make sure it's not a fluke, but it's on point. You make sure your team doesn't spill the beans to anyone outside until everything is known and clear. You get into beast mode with work and try to catch the sound again, and it remains. You can't sleep trying to think of something that could be producing this hum. A few days pass by, and the sound is pretty consistent. If there was some life out there trying to communicate with you, then surely it would have said something that can be deciphered. You analyze the audio files once again, trying to see if it's some phonetic language you don't know. You call in a linguist to see if she can make something out of it. You and the squad gather around, waiting impatiently for some answers. After a while, she believes that it might be someone out there communicating with us, but the only way to find out is by sending something back to them. You arrange a meeting with your team and try to figure out what message you can send. After much thinking and lots of coffee, you decide to send them one phrase in English. Who are you? You send out the signal through Voyager 1 and wait for any changes in the hum, but you don't get anything straight away. It may take some time for a response. You wait all night and still, there's nothing. It's starting to look like there isn't anything out there. For the next couple of days, you keep sending out phrases for anything to pick up. Since space is a vacuum, sound waves can't travel, so sending out voice messages on a large speaker won't work. You locate the source of the humming and aim for it when sending the audio file. Every day, you send something different, but still, you don't hear anything from them for a week. It seems that intelligent life in the distant world isn't real. The areas between the star systems in a galaxy aren't necessarily a complete vacuum. That's where the interstellar medium is. It contains gases, dust, and cosmic rays, which are energy particles. After many months of this constant humming being produced, you still try to figure out what's going on. You sit there, remembering the time when the Voyager was first launched. You remember running outside after playing some video games. You couldn't see properly because of the sun, and you freeze in your spot and have a eureka moment. You go through some notes taken in the past. The answer was in front of you all this time. Every now and then, the sun sends a burst of energy that causes the plasma of interstellar space to vibrate. Scientists can measure the frequency of waves when the plasma vibrates to show how close they are to each other. And on the day when the hum was delivered, there were some irregular frequencies coming from the sun. So that hum might have been the plasma vibrating in a weird way because of the sun flares. But these low-level vibrations last longer than quick jumps and spikes. They're fainter. You run the tests again and find out that it's not some intelligent life forms out there trying to talk to you. It's the little vibrations caused by sun flares. You notify your team about this breakthrough, and everyone's celebrating. But after all these tests and research, you still don't know why plasma in the interstellar medium vibrates in such a way. Those answers will have to wait. 2027. It's been 50 years since the launch of Voyager 1. You're way into your senior years and just retired from NASA. You have many scholarships in your name and programs for young people who want to learn about space and science. You go back to the control room once more, where you thought you had discovered intelligent life on a distant world. Then you remember all the good times you had. You say goodbye to everything, knowing that this is Voyager's final moments. It was built to last up to 50 years. After that, it'll just be a floating object in the vastness of space. It's already surprising to know that this is Earth's most distant object from us, but it's time to let others take your place. You shut off the lights and close the door. The Voyager makes one last beep before eternal silence.
Hey, we landed on the moon. We sailed around the world. Romeo met Juliet. Hey, it's hard to imagine that there are creatures out there who saw it all happen. Immortal animals. Well, almost. Glass sponges are weird little creatures that sit in one place for thousands of years. From their favorite spot under the sea, they witnessed the first Europeans crossing over to the Americas. They can live up to 15,000 years. And what's even cooler is that they can control their aging process, speed it up or slow it down. They have a glass-like exoskeleton for protection. Lobsters can grow back a limb if they lose it, and they're basically immortal. They produce an unlimited number of enzymes that keeps their DNA young forever, and they just keep on growing. That means they outgrow their own shells. They have to shed their exoskeleton every now and then and upgrade to a bigger one. The largest lobster ever caught was 44 pounds off the coast of Nova Scotia. Scientists think this large lobster was around 100 years old. It was around when Edison invented the phonograph. This next creature is a mix between a jellyfish and a tree branch. Each end of the hydra has a ringed foot, and it spends its days chilling by lakes and rivers. Its tentacles grab onto tasty snacks that swim past it. So, what's the secret to its immortality? That's something everyone wants to know. The hydra has the ability to renew its stem cells. Scientists have been trying to do that for years. They can actually slow down their aging process. Now, these little sea creatures are red sea urchins. They sit on seaweed in shallow waters and are immortal. Well, we haven't been studying them long enough to know for sure, but scientists say they only grow in size, not in age. What? Well, they sort of stay like little baby urchins, but grow in size. Adult, baby urchin, okay. These little babies can reach around 100 years old, even 200. The slowest on the list? The giant tortoise. It can reach 200 years old, and one of the oldest is Jonathan. He's technically the oldest crawling land animal. He was born in 1832 and lives it up on a remote island called St. Helena. Jonathan's been through a lot. He's seen the very first American skyscraper, the Eiffel Tower. Oh yeah, he's also lived through every single World Series, starting when he was 71 years old. Now he can't see too well and he's lost his sense of smell, but he's still going strong. Back to the oceans and the Greenland shark. It's been known to be the longest living vertebrate and can live more than 400 years. Swimming around for that long in the deep, dark, cold ocean means these sharks are tough. They're able to withstand insane water pressure. Sharks are one of the only creatures today that haven't been affected too much by evolution. Many sharks have been around since the dinosaurs and haven't changed much. Scientists found out that they grow around ½ an inch per year. So, with a little bit of quick math, they can easily find out the age of these tough sharks. Imagine seeing a shark that's older than the USA. This next creature is probably the most durable, indestructible, and cutest on the list. It's called a tardigrade, but scientists nickname it water bear because I guess it looks like one. But it's not exactly bear size. It has 8 legs and hands with a strange little nose. And these bizarre microscopic creatures are indestructible. They're known to live in the most extreme places on the planet. They're fine with temperatures as high as 300 and as low as minus 330. Volcanoes, frozen desert nights, they can even handle radiation and massive amounts of pressure in the deepest parts of the ocean. They can even survive the vacuum in space. No tiny little spacesuit or anything. Yeah, that would be cute enough. So far, they've survived 10 days on the outside of a spaceship, but they could probably do longer. Tardigrades might be able to outlive humans if there's some sort of worldwide catastrophe. Microscopic organisms in charge of the planet. Wonder what that would look like. Whether it's all the volcanoes erupting at once, or another ice age, or even another pesky asteroid. Tardigrades probably wouldn't even notice. Scientists are studying them to see if they can help us with some next-level biotech. Now, just for fun, here's the mayfly. This poor little insect doesn't even make it past 24 hours on average. Females and males can make it to a whopping 2 days old. Talk about living in the moment. These little flies grow in swarms and are known to have one of the shortest lifespans of any creature. But as a species, well, they've been around for hundreds of millions of years. Jellyfish have discovered the fountain of youth, and surprise, surprise, it's been inside them all along. Not inspirational poster style, but literally, it's always been inside them. Jellyfish are able to reverse their aging process whenever they want. Imagine you're swimming along and then you think to yourself, gee, I kind of want to be 8 again. And poof, there you are. Who wouldn't want to go back to being 8? That's how jellyfish stay young and live stress-free. These brainless and boneless creatures can turn the clock back anytime they want, as long as no one bothers them. They're super chill, just floating in whatever direction the current takes them. Like, go with the flow? This creature looks like something right out of a sci-fi movie, and you could say it has sort of alien features. The giant weta outweighs a mouse and is considered one of the biggest insects out there. You find these big bugs in New Zealand. While jellyfish can reverse their aging process, some members of the weta family can come back to life. Talk about superpowers. If they get completely frozen, they start to make special proteins that stop their organs from getting ruined. After whatever amount of time they're frozen, they can be thawed out and brought back to life, like nothing ever happened. In fact, the giant weta has ears on its knees in its front legs. And because it can resurrect, it's also called the zombie bug. Planaria are flatworms that are unique. Apart from being practically immortal, they're the ultimate regeneration machines for lost body parts. If you take one of them and divide its body into 10 parts, you'll end up with 10 new Planaria. You keep dividing them up, they'll keep multiplying, even though they're usually less than an inch long. Imagine if we could figure out how to do that. Would that be a way for us to live forever? Or would we end up with a totally crazy world with copies of everyone walking around? How about the world's fastest relay team, 4 identical Usain Bolts? Now, clams have been around for a really long time. Scientists have discovered that they can live up to 400 years old. These little shelled creatures are the ones that create those shiny little pearls everyone loves. A clam will go into action mode when a parasite gets inside. The clam tries to cover the parasite with a bunch of special chemicals, the same ones it uses to make the inside of its shell. That's when the magic starts to happen. When these chemicals harden up, they make a shiny, glossy pearl. The more chemicals, the bigger the pearl. Now, this long, slippery-looking creature lives deep in the caves of Europe. Olm can live up to be 100 years old. It spends its days hunting for little insects, snails, and crabs with its tiny front arms and wriggling snake-like body. Its skin is so pale that some locals even call it the human fish. Hey, wait a minute. The olm is almost blind, but it can still detect light. It just mostly does it through its skin. Like other blind animals, it has a supercharged sense of hearing and smell. It gets its distinct look from those little red gills around its neck.
On the moon, iron is preserved in pristine condition because there's no oxygen. It simply can't rust there. But just a couple of weeks ago, scientists made an unexpected discovery. In the higher regions of our satellite, iron is oxidized and actually rusting. At first, this finding perplexed astronomers to no end. The presence of rust might mean people can breathe, at least in certain areas of the moon. But then, the explanation surfaced. Oxygen might have got to the lifeless rock from our own planet. In the absence of atmosphere, solar winds beat the moon relentlessly, and nothing can stop them. These flares could swoop some oxygen from the upper layers of the Earth's atmosphere and carry it all the way to the moon. The molecules then come to rest at the highest points of the moon's surface. That would explain why metals don't get oxidized in the ravines, and especially under the surface of the satellite. While we're on this topic, the moon has long been believed to have formed as a result of a humongous impact with the Earth. A Mars-sized celestial body could have driven itself into our planet and made part of its crust shatter. The resulting debris then packed together in a tight ball, which later became our moon. But there's one question that's been bugging scientists. The Earth's crust is poor in metals. So how come the moon has so much metal within it? The latest research basically throws the main theory out the window. So in 2020, we again know nothing about our closest neighbors coming to existence. There's news from the further reaches of outer space, however. Astronomers from MIT registered a repeating signal from 500 million light-years away. Such signals are called fast radio bursts, or FRBs, and they're usually singular events. No one knows what their sources are, but they could be supernovae, or bursts of energy from quasars. This repeating one, though, is pretty creepy, because it's regular. For 4 days, radio equipment captures signals all the time, and then they abruptly stop. But after 12 days, the same pattern begins. 4 days of constant radio bursts, and 12 more days of silence. Astronomers managed to locate the signal as coming from a galaxy 500 million light-years away from us. But what causes it is still unknown. It may be a spinning quasar or a supermassive black hole, but an alien technology is not excluded either. Speaking of which, there just might be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of a comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures. Microbes, at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only inhabitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of sun-like stars and Earth-like planets, and some of them are surely more like ours than others. One such planet can be closer than you think. Venus, the Earth's evil sister, might be home to microscopic life. Even though its surface is as hot as a furnace and showered by acid rains from carbon dioxide clouds, there might be something alive in its atmosphere. Scientists have recently picked up traces of a gas called phosphine that can be produced by microorganisms. In very small amounts, it could appear by non-organic means, but telescopes have found much more of this gas. This discovery came as a huge surprise because Venus was believed to be too hostile for any forms of life. Now, though, it might become the first ever planet, apart from Earth, to be home to living creatures. The microbes that produce phosphine probably live in the acidic clouds, and they don't need oxygen to survive. Another promising world has been suddenly found while rummaging through old space telescope data. In 2018, astronomers analyzed information received from the Kepler telescope and, as usual, disregarded pieces they didn't think were relevant. But 2 years later, while going through this old data, scientists noticed that one object was misidentified. It turned out to be an exoplanet 300 light-years away from Earth, and so much similar to it that it was almost a doppelganger to our home. Kepler 1649c is only 6% larger than Earth, and probably consists of the same minerals. It also receives about as much light and energy from its star as we receive from the Sun. The only problem for now is that the star could flare up too often, making the surface of the planet too hot and scorching its atmosphere. Still, there's no proof of it yet, and we could have a potentially habitable planet pretty close to home. AU Microscopii, or AU Mic for short, is basically a cradle of a new star system that can be observed directly. It's really close, only 32 light-years away, and the star is very young, around 150 times younger than our Sun. On a cosmic scale, it's like a newborn baby, and you can still see a cloud of debris swirling around it from the time it was born. But the curiosities don't stop there. NASA added a poster featuring AU Mic to its Galaxy of Horrors series because of the planet that orbits the star. AU Mic B is so close to its Sun that it makes a full circle around it in just 8.5 days. Being so young, the star frequently throws tantrums, resulting in horrible doses of solar radiation storming the poor planet. As you may guess, no life is possible in such conditions. Still, the scientists are happy to have found this system because it sheds light on how stars and stellar systems are formed. Back to Earth now. The climate changes we're witnessing are most probably part of a natural cycle. Researchers from the University of California, Santa Cruz have devised a pattern in our planet's climate variations, and they look like extremely long seasons. Sometimes, these states could last for millions of years, and they're all related to how the Earth is positioned relative to the Sun. The seasons were dubbed Ice House, Cool House, Warm House, and Hot House, according to the prevalent temperatures. For the past 3 million years, for example, our planet has been in the state of Ice House since the last ice age was not so long ago. But humanity's actions, adding to the greenhouse effect, have pushed the climate state to Warm House much faster than it would have come without us. When it finally comes, the overall temperature on Earth will rise to tropical values, something that the planet hasn't seen in over 50 million years. What a time to be alive! Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance, thanks to which we can now thrive. But there's now a new advance which suggests another scenario. In space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth, not only thanks to fossilized remains of living beings, but from outer space as well. Remember the huge asteroid that led to the extinction of the dinosaurs? Well, I wasn't around then, but scientists say it could be caused by something entirely different. At least one mass extinction was probably a result of a supernova explosion far, far away from our planet. A starburst as powerful as you can imagine lit the Earth brighter than the sun one day, and soon its UV and cosmic rays reached the ozone layer of our planet. As they did, the planet's protective cover was burnt away, and everything that was below suffered the consequences. It took the Earth hundreds of thousands of years to recover from that onslaught, and if it happens again, which it might, we won't be able to survive. Luckily, the closest event like this is the explosion of Betelgeuse, and that star is way too far from us to do any serious harm.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.